I just want to grab your attention for I don't know, 50 minutes or something like that, But I want your attention now. We are going to spend most of our time today doing the Centripetal acceleration lab analysis, which you took all the data yesterday, you took some data yesterday, you took a little bit of data yesterday. Whatever you did, that's as much data as you're going to take, unless you really, really desperately want to come in and get more data later. This is one of those labs where it's about the process, right? And now, even if you didn't get a full set of data, you have enough information to move forward. Does that make sense? You have the experience, and I can fill in some data if you need it, okay? So we're going to do the analysis today. It's going to take most of the day today, and I want to be really clear. It's not something that I'm going to test you on how to do this again, but just because I'm not going to test you on it doesn't mean that it's not important. Does that make sense? I still want you to understand it, and I still want you to have gone through the process. That's the big deal. If we have time at the end, we can spend some time working on the circular motion problems. Those were the Muppets problems that I sent you on Wednesday during that snow day that I said, absolutely make sure you do them. And the reason for that, just a friendly reminder, is that we are going to have our quiz over circular motion on Monday the 25th. Okay, so that's the next day I see you will be Monday, and we'll do a quiz. The quiz will have some conceptual questions about about circular motion, centripetal acceleration, and there'll also be a quantitative question or two, okay? Probably it will look either like a car going around a circle or like a roller coaster loop-the-loop or a silly silo question, I'm guessing, given that those are the three questions that we've spent time with, right? So if you want to know what to study, that would be what to study, okay? I feel like there was one other logistical thing I needed to tell you, but I don't know what it was. So what I'd like for you to do right now, all of the centripetal acceleration labs that you turned in to me, because I wanted to look at them last night, are sitting right here next to Clay. So you need to do that. And then everybody needs a Chromebook out, okay? So please make that happen, and then meet me with your Chromebook out and Google Sheets open. It was just kind of a cute noise, and I wanted to make sure you're okay. All right. So as you're organizing your Google Sheets document, you can set this up in lots of different ways. Probably some could argue maybe not quite an infinite number, but a lot of iterations. This is the way that I'm going to set it up. So if you're not super comfortable with Google Sheets, then I would just follow this, just so that you kind of have a sense of what to do, okay? So we're going to put data in a minute, but I want you to go ahead and set up the beginning of this chart right now so that you've got something to work with. I'm going to zoom it out just a little bit so you can see all the other headings that I have, okay? Now it's kind of little. It's hard to see. But I want you to just take a look at that. Does everybody has a Chromebook to use? Is that right? Anybody need to borrow one? Are we good? All right. I'm going to give you a minute just to set that up. Now, as you're doing this, I'm going to get you started with a little bit of data here. So we want, and I'm sure that I said this to you the last time that we worked on this, and I'll zoom back out again in a minute, but I just want to make sure that you can see what I'm doing. We want to make Google Sheets work for us, right? We don't want to make it harder. We want to make it easier to do it. So as you're going through and figure out the number of washers, like you could write that, just go ahead and write those numbers in. I think that the ones I stole had those as the values. So you can go ahead and write that in, and then don't even put anything here yet, because probably what you did is mass just one washer, right? Is that true, or did you mass all of them? If you masked all of them, you can type those numbers in. Otherwise, leave that blank. Too far ahead, mostly because I want to make sure that you're using Google Sheets to your advantage. So once you've got the number of washers, if you wrote down the mass of one washer, I went ahead and put that over here. A friendly reminder that I'll give you a few times probably throughout the day is that when you're putting numbers in, you don't want to put any labels in with the numbers, because we want to be able to calculate with these numbers, and the only way we can calculate with them is if they don't have labels with them. So the labels go up above, okay? Here's the first one for you. So we're going to click on mass of washers. And again, if you didn't do it this way, that's okay, but I just want to show you how to do this. remember, whenever you're doing Google Sheets and you want it to calculate for you, say equals. And I'm going to say that I've got 4 washers. I'm going to multiply. And remember, multiply is the asterisk. So it's shift 8. And then I've got the mass of the washer. I'm just going to click right over here. And so this is saying now, Google Sheets, multiply this number by this number. Okay? The nice thing about this is that then we can make it do our work for us, right? Now, I'm going to tell you one quick thing, though, and that is that in the handy-dandy setup that Google Sheets does for you, we can drag this down, if you remember that from before. We want to drag this number because we want it to be 4, then 6, then 8, then 10, then 12. But we don't want this one to change. So instead of just dragging it down, because then this will be just 0, and that won't make any sense, we want to say, stay H5. It's always going to stay H5. And the way you do that, I don't know who made this up, but somebody decided that the way you do that is by putting a money sign. Why? I don't know. Somebody made that decision, and that's just the way it's gone. So now the nice thing is, I'm going to go down here. I hit enter. I'm going to click on the little box at the bottom and drag. And now it did all that math for me. And I just want to show you here that if you look way up here in this little corner, it says A6, which is that one, times, it's still H2. So it's still multiplying by this number here. Okay? So once you've got that done, go ahead and put your data in for your trials. Okay? I'm going to pause for a minute and make sure we're doing okay. Go ahead and put your data in for your trials, and then we'll regroup in just a sec. Yeah, go ahead.
How did you highlight
On this part? Like, do you want me to just go through that one more time? Sure. So I'll just delete it here. Let's just go back. Okay. So I'm going to hit equals. And then all I do, I'm just going to use my mouse to click on the boxes that I want. So I click on the A2 box and it puts it in there. Does that answer the question you're asking?
Can you type it?
You can. Yep. And that will work as well. So you can type in H $2. Yep. Did that answer the question you're asking? Okay.
But then you would just click on that box.
Yep. Some of you are feeling like you're not quite there, but I would like to just grab your attention for a minute so I can go the next little step here with you. So you hopefully have your trials in. Now we're going to find the average period, the average time it takes for it to go around one time. So I talked to one person at least that did it a little differently, which is fine. Your numbers when you did this should be like on the order of partial seconds. If you have numbers that are like 7 or 8, I want you to think about that for a minute. 8 would mean it takes 8 seconds. 1, 1,000, 2, 1,000, right? You with me? Yeah, to go all the way around. That does not make sense. So probably you did like a few revolutions you need to divide, okay? For average time, again, we're going to make the computer work for us. We don't want to have to work. Average time, we're going to type in equals. Then we're going to type in AVERAGE because you're saying, oh, I'm frozen. You can't see it. Sorry. There you go. Average equals AVERAGE. You're saying Google Sheets, take an average. It says, okay, sure, we'll do it. Right? Open parenthesis. And then you're going to highlight the numbers that you want to take the average of. Close parenthesis. Hit enter. Boom. Oops. Go back up there. Drag it down. Okay. So go ahead and find that average. And then also, if you have not yet done so, because I didn't have this one over there before, make sure that you've included the radius because we're going to need that in the next step. Okay. I'll come check on you guys again. At this point, you have a lot of information. I want to go back actually to the whole point of this lab and what we were doing so that you can get a sense of purpose, perhaps. Okay. So this is really what we were trying to look at. I told you when we started this at the beginning of the week that I was going to try and help you to prove this, right? So this big mess is the thing that I want to prove. Do we know the mass of the washers? Yeah. Do we know the mass of the stopper? Yeah, I hope so. Do we know the radius? Do we know the period? Yeah. So we know everything in there. Now you can do this one trial at a time, which is a bad idea. Okay. Or we can be a little bit more clever with our physics. And that's what I want to do. So I'm going to, oops, I guess I stole it right there already. So I'm just going to say copy. And we're going to throw it in again. And I'm going to write this down. And you might want to write this down in your lab as well, just so you have it to kind of look at and reference if you need it. Okay. So I'm just going to remind myself that this was the equation that we said that we were going to map. And I like lines. How do you guys feel about lines? I mean, like of all the things you're going to graph, I feel positively about lines because they're pretty straightforward. What's the general equation for a line? Y equals, what was it? Yeah, and we know everything about y equals mx plus b. We know what y means. We know what x means. M is the what? Slope, right? And b is the, what is b? The y-intercept, yeah. Now my argument, this seems a little bit weird when you haven't looked at this. So friends, I want everybody to pay attention. I'll give you some more time to work on your data in a little bit, but I'd like you to pay attention up here so that you understand what we're doing. So this ugly looking blue thing, I argue is exactly like that pretty little pink thing, okay? They're the same. Now you might be like, I don't think so, but let me show you what I'm talking about. So I have something equals something times something. You with me? Something equals something times something. Let's look at it. My y value is just going to be the mass of the washers times gravity. I know the mass of the washers for each case, right? And gravity's 9.8. Got that. Okay. I know that this thing is multiplying here. This little guy right here. Whee! That's going to be my slope. The slope of my line is going to be the mass of my stopper. So this is really the thing that I'm going to say, oh, is it really equal? I can look and see. And this, the rest of this nastiness right here, that is going to be my x. The reason that's going to be my x is so that I've just got this nice, happy little slope. So that's what we're going to do. We're going to say all of this yuckiness is going to go in for x. And it'll take a minute to get it in there, but we've got this. I believe in you. 2 pi r over t all squared divided by r. It's gross. I agree 100%. But we know all this stuff, right? We know the radius. We know the period. We know the radius. We know 2 and pi. We're good. So if we can plug all of that in for x, we can plug this product in for y, we've got our slope. Okay? I'm going to write this down on the board so that I don't have to jump back and forth. So I'm going to say that y is equal to, and this would be what, if you wanted to write something down on your lab, this is what I would write down. So y is equal to the mass of the washers times the acceleration due to gravity, and x is going to be equal to 2 pi r divided by t all squared divided by r. Okay? How are we doing? We okay? So we're going to set that up on our Google Sheets. It's going to be great. I'm super excited. Here it comes. Are you ready? Let's do it. I'm just going to come down here. I'm going to make a chart that says y and x. I'm going to make my y's first, mostly because it's easier. Under y, I'm going to say equals. And what is it that's going to be my y, friends? Mass of the washers times gravity. So I need to find the mass of the washers. Oh, it's right there. That's cute. And then I'm going to multiply that by gravity, which is acceleration due to, what is that? 9.8. Boom. Do it once and drag it down. How'd we do? Are we okay so far? The answer can be no. So I clicked on B2, which is the mass of my washers. I'm just multiplying by 9.8 because that's my acceleration due to gravity. I hit enter, and then I grab out of this corner and I drag it down. Clear. Your enthusiasm was just great. All right, here we go. So now, I promised you that we're going to plug a little nastiness in, and that's this big thing here. So it's going to take a deep breath together, but we got this. We can do it. So in and out. We're gonna make it work for us, right? So we're going to start with an equal sign. We're going to start with an equal sign. And then, because this thing has got so many pieces, we're going to use lots and lots of parentheses. Lots of parentheses. Parentheses make everything better. I'm going to add 3. I think that's the right number. So go ahead and add 3 open parentheses. Okay? And then we're just going to plug this in one little step at a time. That's all we're doing. One little step at a time. So the first thing that we need to add is 2. I can do that one, right? 2 is no problem. No problem. What's the next thing we need to add? Pi. Now, 3.14159, right? Like, sure. The nice thing about Google Sheets is it's smarter than that. It doesn't have it just out to 4 decimal points. It has it out to a lot of decimal points, right? They got lots of storage space. So we're gonna use the knowledge. So I'm gonna say times, okay? Capital P, capital I. Oops, that was little p because I had a P-I, parenthesis. That tells us, that says use the function that is called pi. Okay. All right. So now I've got 2 pi. Now what do I need to multiply by? The radius. Do we have the radius? Oh, yeah, we do. So we're going to go ahead and click on it. Boom. So mine was up here, measured in meters. Okay. Find that? Now, we know, because we want to make this easy for us, that we're going to drag this down. When we drag this down, do we want this one to change? Do we want that radius to change? No. So do you remember what we used to make it not change? Good job, friends. So I'm going to put my cursor in between my I and my 2. Say $, please. Okay. 2 pi r. That's it right there. Parenthesis. Close that first parenthesis. That's the numerator of this mess. What am I going to do with it? Divide it by, we're going to square it soon, but we're going to divide by t first. So I'm going to divide by, and then I'm going to put in my t's, right? These are the things that I measured. So there it is. Okay. This one I do want to change as I scroll down because my time is the thing that changed every time. So no $signs for the T one. Madeline, you look perplexed. What can I do to help you, darling?
I just figured out that my phones were off. I was trying to figure out why you were putting an F2 and mine's actually on.
Oh,
so
yes. Is it okay now?
Yes.
Okay, awesome. Yep. And that's the tricky thing, right? Is that if you don't put it exactly the same place I do, it's not going to look exactly the same. But that doesn't mean it's wrong. It just means you have to adjust a little bit. All right. Are we ready next? We're going to close that parenthesis. So that's this big parenthesis up here. What are we going to do with everything inside that parenthesis, friends? Square it. To square it, you use the caret. It rhymes. It's kind of, I just discovered that earlier today. Caret 2. Okay. And then we have to do one more thing. I'm going to put another parenthesis. Divide by radius. And oh yeah, by the way, we don't want that radius to change, do we? So let's $sign that one too. Okay. I'm going to go ahead and click and tell it to go, and then I'll put this back up so you can see it better. Does that make sense? So when you want it to go, then you hit enter. Oops. Click on the corner and drag down. And there it is. Life is easy. I know, right? Isn't it cool? All right. So once you've got this, now all we have to do is graph it. Now, I was just talking to a couple of groups here. Your data may not be fantastic. That's okay with me. What I want for you to understand, honestly, what I want for you to understand in this lab is, that's really big. I want you to understand this, okay? I want you to understand that there's a relationship here. And then from a lab perspective, I want you to understand how you take data and what things affect other things. Am I going to quiz you on Monday over this material? Of course not. No, this is lab skill stuff, and it's important, but it's not going to be on a test, okay? But that doesn't mean that we shouldn't do it, okay? I just want to make that really clear. I don't want you to stress out if your data is not good. It's okay. We're learning. All right, you ready? Let's do it. I'm going to go to Insert, and I'm going to go to Chart. Now, I'm going to tell you a couple things. Google Sheets often thinks that it's smarter than me. And I'm going to give it credit. It can do calculations a lot faster than I can, right? But I know what I want this to do, so it's not going to give me what I want to start. We just got to get something there. There's no data. There you go. First thing that I want it not to do is I don't want it to be a column. What kind of charts do we do in physics? Physics charts? We do scatter plots. You want a scatter plot, so tell it scatter plot. You know what? I lied. We're going to start over. Sorry. Get rid of that graph. I changed my mind. Sorry, get rid of that graph. Highlight your data, your X and Y stuff. It's going to be a little bit better this way, I think. So highlight your X and Y stuff, and then tell it to insert a chart. It's still going to be gross because it still thinks it wants to be a column. We say, no, thank you. We're in physics. We do a scatter plot. And then it's still going to think it's smarter than us. We say again, you're not smarter than me. What's up, Madeline? Say again? Like these guys?
Yeah.
I just clicked and then dragged. I can come over and help you in just a sec. Does that sound okay? All right. Did you figure it out, Madeline?
Yeah.
Okay, awesome. All right. So now I'm going to go through this real quick, and then I can come around and help you out individually. But I want you all to pay attention for just a minute because I want to make sure that you hear all of these details. Because again, Google Sheets thinks it's a lot smarter than us. But is it, Clay? No. All right. Do you see this thing that says x-axis? You need to tell it what's on the x-axis. So you're going to click this little window pane. It says, okay, well, tell me what you want on the x-axis. And you'll say, sure thing. You're going to highlight just the things that you have labeled X. Just those 3 or 5 or 7 numbers, whatever you have there. And then click OK. And then, do you see where it says series? Right over here, right underneath x-axis. There are 2 things because it thinks, again, it knows what it's doing and it doesn't. We're going to delete one of them. It does not matter which one. Just say remove. Bye-bye. And then edit. I'm going to pause there for a minute. Make sure you guys are with me. Are you okay?
No.
Okay.
After the part where you...
Did you get the x-axis?
Yeah, I think.
Yeah.
Okay. So then underneath x-axis it says series, and there may be 2 of them. If there are 2 of them, click on the little 3 dots on the side and say remove to one of them. It does not matter which one. And then on the other one, instead of removing, say edit. Okay? The series is your Y values. So you're going to select your Ys and click OK. And now, hopefully,
you've got something resembling a line. Now that very well might not be true. I'm going to come around and just check in with you a little bit, and then I'll go back and we'll do. So we've got something that resembles a line or should resemble a line, right? And I want you again to know that it's okay either way, but let's figure out what we can do to like finish up and finalize this. And by that I mean at the end of the day, and by that I mean kind of the end of this project, I would like for you to be able to turn in something. You will get credit for collecting data. I saw you all doing it, so that's all good. You've entered data and calculations in Google Sheets. You're going to graph it. We graphed it. You need to do these three things still, and I'm going to help you with that to show you how to do that in a minute. And then you're going to calculate your percent error. I'll show you where to do that. And you'll turn this into me, and I'll put this up on Canvas too so you have it. Don't worry. But by Tuesday, because I know you've got the quiz to worry about and other stuff to worry about. So just get this to me by Tuesday. You'll do that just by sharing your Google Sheet with me with your name on it, and it'll all make sense. Does that make sense? Okay, so that's what we're going for. So let me show you these last few bits. So one is, how do we know what the equation of the line is? Well, we're going to go to Customize. Okay. And then to Series. So over to Customize and then to Series. And then if you scroll down, there's one that's the very last one. It says Trend Line. And that's going to give you maybe a line. Well, it'll give you a line of some sort. It might not be right or wrong. That's okay, right? Physics experiments don't always work, and that's fine. But we understand the theory behind it. That's what matters. Okay? And then to figure out how good or bad your data is, if you scroll down just a little bit more, where it says Label, you can click on that and say Use Equation. And then it's going to give you the equation of the line, y equals mx plus b. So this thing here is the slope of your line. And friends, what does the slope of your line represent? Do you remember? Let's look. Let's look. What does the slope of my line represent? The mass of the stopper. Okay, so that's what we're going for. Now, again, if your values aren't good, it's okay. We're learning from it, right? It's all good. It's fine. So that's how you're going to get your slope to do your percent error, okay? When you are doing your labels, because you'll also need some labels, if you go to the menu that says Chart and Axis Titles, and there's a little menu that says Chart Title. It's a drop-down menu. So you can add a title, and then you can also add horizontal axis title and vertical axis title. There. Okay. What else would you need to do? I don't even know. I think that's pretty much it, right? That's kind of all the little pieces that go with this. You can make it pretty or not, like whatever you feel inclined to do. Okay. I'm going to come around one more time to make sure that everybody's feeling okay. If you want to go ahead and put your labels in now, you can do that, and then you can, be almost done. Okay. But either way, like I said, this is going to be due on Tuesday. You'll share it with me, and it'll be great. Okay.